Hey everyone. In previous video, we have seen the foundation and the usage of tools and decision making between agents, how that happens. So in this video, we're just going to see a complete multi-agent system with a core of these topics that we have seen in previous episodes. So I have included memory and state and planning mode for agent and multi-agent system orchestrated using LangChain or LangGraph, which would be using a RAG a model inside. So what memory and state does is it remembers every state of information that agent and the user have conversated, and also the retrieval and response which would be stored, so that at any point of time the user comes back and asks the agent, it responds with the updated information that it have in a memory. So planning is made by agents by certain research tools that have included, and whatever it is going to do as an agent, which user asks do. So whenever it decides on certain things, I have also included an human approval form where it gets back to user whenever it needs an approval to proceed with the task that we asked it to do. So that is the planning mode. And when it comes to multi-agent, as I said before, it is going to orchestrated using LangGraph or LangChain. And retrieval augmented generation is the one which is going to use the vector DB, because we are handling memory and state in here, and also human conversation is actually happening. So it need to understand in terms of agent in order to process. So let's see how these code is happening in between. If you didn't or not understanding any of the part about agents or handling multi-agents, refer my previous episodes so that you will get an idea of. Okay, first we are starting with agents. So for that, again, I'm using Gemini as to have a flow. So here we have a function called call Gemini. So the model would be called whenever the agent is pushed into a task. And we have a planner agent. The task is to make plans for every task that is given to it. So it just assign plan like what it need to do and what all things that it need to refer, where to call, and who to get approval with. So it plans every user instruction, and it manages the session ID also. So I've given in order to handle the memory. And we have agent 2, which is research agent. This agent will research on topics which have been given to it. So any tool that it need to be used, we have given tools also. I'll explain that. So research agent job is to research. That's all on out of view. And it calls Gemini. So whenever we are giving it to a task that need to be managed, it understands through LLM. So LLM is a kind of a translator for them or a representative. So whenever they need or send results to user, whenever it have a user interface or a user conversation should happen, then LLM supposed to be there in order to bring back those information and agent to agent communication. So for the result sharing, we need LLM, and also for the user understanding, we need LLM. Like a communicator, someone who's in between, a mediator kind of, that's LLM. Without LLM, agent cannot communicate within or outside. Next, we have a write agent. Writer agent will work together with research agent. Whenever he shares information to it, it starts writing. Before that, it need a approval or feedback from user. So that is also there been included. So reviewer is a one. Whenever the write agent asks whether I'm going in a right direction, it approves, it instructs. and that approval have been given by a user sometimes, and LLM would get back those information. So this is how it is happening in backend as an agent. Now we'll move to in terms of tools. We have a web search. So it is application where we're going to have a blog. We're going to write or automate writing a blog about AI or ML. So that is our use case. So as per that, we have those agents, and for that we need this particular tool called web search. So it searches online and does call the agents allocated for every task at it. So we have a given like source of information, which is vector DB. Why vector DB is because it need to know what all it have been written so far. Whenever the user comes in after like so many approvals and rejections, it should get back to the last approved information or last rejected information, so that it won't repeat the mistakes again. And if even after a few days or any time they are coming back, it should know where they actually stopped. For that, we just given the information of vector DB, and we'll go into this memory storage before getting to the yeah. So we have memory, which I'm including a chroma, and we need embeddings for that, because we need to convert text into numerical format so that machine can understand. That's how LLM understands and takes to the agents. And the memory state we are managing, so that we something like session ID or anything that we can say, so that we don't lose any track of it. So we are having a state and events for it. So for that, we are using LangChain that we will see. But for memory state, we are just pulling those information for it. So it's nothing but a user memory, and also machine memory is also handled in here, which is in here. So memory type that I'm giving. So topic wise, it will be added in using memory ID. So this is user memory. The user, whenever the user asks, that also would be stored. So entire conversation you will have, and search relevant memory. So we just assigned for each task a memory, like a title we have given, so that it is easy to refer for user as well as LLMs based on the ID. And we are going into this graph before going into communication part. So as I said, we are using LangGraph. LangChain, why we didn't have? Because it is a linear format of having orchestration, I mean getting together. But when I go with LangGraph, it can handle multiple state, like you can have up and down, any agent that you can continue working with, or in loops. Whenever there is a loop, we have agent call, and the event based and session ID have been managed very well with LangGraph compared to LangChain, because this is not a linear model. So we have human approval node in here. Every agent, the roots have been managed, and all the agents have been added in nodes with the help of Edge, the planner, researcher, writer. We have everything in here, and human approval. So we have all those, and this communication is happening all together with the help of MCP. As we see, this is a very complex system. Uh, if we are like getting into big picture, it involves like lot of conversation back and forth between agents, between user and agents, and inside the model where it searches the web and gets back the result. If the information is already taken, it need to eliminate and research back with the help of reviewer. So all these things which would be taken and constructed with the help of MCP. Without model context protocol, it is hard to manage the state and LLM calls. So for that, we are using LLM. So we have like read and write. So whenever there is a data comes in, it just takes to the appropriate agent or tool. Likewise, we just gave the updated context. So any information that have been updated, like response, it may be yes or no, or approved or rejected. That updated information, which would be taken to a respective agent or a tool, or any conversation loop it is currently in. So that session ID have been managed. So every thing that is managed with a vector DB, and we are assigned with an ID, a specific ID for it. That is how this entire communication is happening. And I didn't write like much of a rule for it. It's a simple rule that you can understand data, where we are calling using session ID whenever there is a new update in it. Same goes with the context, like new context and a particular context that ends with a proper relevant messages that it is getting. So I'm just giving it as an field. So new field, new context, updated information, everything we have like called with a read and write operation. Yeah. So read and write operation have been given. So reads and it writes. Next. Yeah, we have seen this and graph. At last, we have main. Main is um, a calling function. I mean, the main function where we just operate this entire system, agent system in one go. So now let's see how it works. You can see the chroma DB have been created. So the planner agent have started. Since it's a demo video, I just asked it to make like 4 lines. So we can see the communication here. So plan has been made and memory used, research notes. How the MCP actually communicating, help the agent to communicate. So you can see it is getting updated. So finally it is asking me to approve. I need to read this whether it is okay or not okay. Do I need to add anything? I can add. So this is how the entire model works. So verdict is waiting for my approval. Let me approve this. What if I say no? What should I change? So this is asking me. This will be it works too many. Uh, I- So this communication is happening with the help of LLM. So it is assigned version 1 now. So previously it was version 0, and yeah, we have it in bulletin. Okay. Now I'm approving this. So this verdict you're seeing is a reviewer agent, which is Cave. So save to final blog post. So we have the blog in here, which was given, which I approved now. This was the bulletins in here. Yeah. Okay. So that's all I have for today. I just made this session in order to have like overall view how this agentic flow happens in terms of memory, and we have the orchestrated using LangGraph and this MCP communication. So it is a big picture, it is a huge model, but I just wanted to make it like very simple so that everybody who's like new can understand this. So see you all next session or episode. Thanks for watching. Bye.